an interdisciplinary group of bioengineering senior design students and senior nursing students at the University of Pittsburgh working on our senior design project in collaboration with Weiser.
I'm Jess Brown.
I'm Tyler Bray.
I'm Maddie Hobbs.
I'm Jacob Meadows.
And I'm Marlo Garrison. People often describe the birth of their child as the best day of their lives. Unfortunately, for 125,000 women in this country, this day is ruined by postpartum hemorrhage, which is excessive bleeding following the birth of a child. Postpartum hemorrhage is the leading cause of maternal mortality in this country. Despite this, 74% of these deaths are deemed preventable. Women die from postpartum hemorrhage because they fail to receive early initiation of effective intervention.
We spoke with obstetricians to better understand this problem, and we learned that labor and delivery nurses are often the first line of defense at recognizing the initial signs of hemorrhage and initiating early intervention. But these are just a couple of their many responsibilities following a birth. Novice labor and delivery nurses are often delayed at initializing early interventions for hemorrhage.
One approach to help clinicians and physicians better understand new techniques and prepare for different clinical scenarios is simulation-based training. Based on initial conversations with folks at the Weiser as well as other simulation centers across the country, we found that existing labor and delivery simulators were being used to model postpartum hemorrhage, but were still insufficient to help labor and delivery nurses better prepare and fully manage a postpartum hemorrhage.
So as a solution, we created DAPHNE, a dynamic and accessible postpartum hemorrhage novice education. So we help novice labor and delivery nurses to recognize postpartum hemorrhage by practicing quantification of blood loss and help them train to initially manage postpartum hemorrhage by conducting a fundal massage. So right now our model actually simulates the most common cause of postpartum hemorrhage, uterine atony, where the blood vessels aren't being clamped down by the uterus. And so there's excessive blood flow, and then the nurse needs to come up and actually do a fundal massage, and the simulation operator can then modulate the blood flow and firmness of the uterus along with vital signs using a true monitor.
So our progress doesn't end here. Next semester we plan to verify our design as well as validate it with novice labor and delivery nurses in an IRB approved study in 3 different scenarios mimicking the 3 most common causes of postpartum hemorrhage, retained placenta, lacerations, as well as uterine atony.
So overall, we hope that this device will help novice labor and delivery nurses initially recognize and manage a postpartum hemorrhage. These preventable deaths need to be prevented. Help us keep this day the happiest day of a mother's life.
So here, DAPHNE is simulating the most common cause of postpartum hemorrhage called uterine atony, where the uterus hasn't fully contracted down on the blood vessels that have ruptured during delivery. So first, we're going to have our nurse come in.
Hi, Miss Daphne. I'm Allie. I'll be your nurse today. I'm going to be performing a quick assessment on you just to make sure everything's okay. All right? I'm going to start by feeling the uterus. Seems like I can't accurately define the fundus, the location of the fundus. It feels very soft and boggy. So next, as I'm pressing on your uterus, I'm just going to check for some lochia, and it seems as if there's a little bit of bleeding. So I'm going to continue to perform a fundal massage and see if this can maybe stop some of the bleeding in hopes that it will stop.
So right now, as the labor and delivery nurse is doing a fundal massage, the dynamic uterus inside of DAPHNE is actually turning from large and boggy to smaller and firm. And so, Allie, you should actually start to feel that the fundus should start to be firming up. Is that what you feel right now?
Yeah, I can start to feel the fundus a little bit, but not fully defined. It's getting there though.
And also right now, the simulation operator could be controlling both the physiologic signs on a true monitor or other system, and also modulating the blood flow to either decrease the blood flow rate based on this fundal massage, or if a cause is not uterine atony in a different scenario, it could be continuing at the same rate.
I'm starting to feel the fundus a lot more. It seems more defined now. So, all right, I'm still going to give the doctor a call and just let him know what I found, but otherwise everything else seemed okay now that you're a little bit better.
Now we're going to take a look and see how DAPHNE works.
So one of the first components of DAPHNE underneath the belly is the uterus and the fundus underneath. Basically, the fundus is the top of the uterus. So what we did to model this is that you will interface with the abdomen, and underneath will be a bag full of fluid. This simulates the boggy state of the uterus when it has not contracted fully and should be cause for alarm for the nurse. So what will happen is the nurse will start to massage this bag fluid, and we have a solenoid valve here. And when the operator decides that their massage has been correct, they will click the valve and the water will flow out of the bag. Underneath the bag will reveal a 3D printed anatomically correct uterus, and the nurse will start to feel this solid uterus underneath as their massage goes on. So it'll go from a boggy, bag-filled state to a solid 3D printed uterus underneath.
One of the important design components of this is that it interfaces with the existing Noel system. So we have a laser cut base that fits within the abdominal cavity and attaches using existing hardware to the mannequin itself, and has slots and screw holes cut for the other components.
Additionally, we wanted to make this as physiologically accurate as possible. Therefore, we have blood running through the mannequin, which we have worked to create as physiologically close to blood as possible, as well as we have a cover for the IB pole to ensure that the simulation users and participants cannot see how much blood is being released, to really test their estimation and accuracy in being able to assess postpartum hemorrhage.
So the blood system is all controlled by a microcontroller system over here with peristaltic pumps. And so right now the blood system is on, and we can actually control both either the rate at which the blood is flowing and also the total amount of blood that flows over the whole length of the simulation. And so the operator can control both the state of the fundus during the simulation and whether the blood is on or at full capacity during that, and drawing from the IV bags, which are usually covered so that the person can't tell what's happening just based on watching the bags themselves.
So we took our DAPHNE device to the Swanson School of Engineering Design Expo, and we received first place in the bioengineering category.
Some future design improvements we are looking to make is to create a molded skin for the abdomen to more accurately reflect the anatomy, as well as integrating clots into the blood loss system to more accurately reflect the physiology. We're also looking to automate the electronic controls of the components.
Moving into next semester, we're hoping to verify and validate DAPHNE in hopes that she will be able to be used to improve novice nurses' training.
So working with Weiser has been an integral part of our design process. Earlier in the semester, our team met with Tom to talk about testing one of our earlier ideas when he brought up the idea that there's not a good way to train nurses how to deal with postpartum hemorrhage. Our team conducted a needs assessment with 3 other simulation centers around the country to confirm this. Throughout the semester, our team came back to Weiser 5 or 6 times to go over different iterations of our design and receive feedback. Weiser also let us take the Noel simulator and True Monitor system to the Design Expo so that we could display our entire design. And we will be coming back to Weiser in the spring to further validate our test with novice nurses. We would also like to thank Dr. John O'Donnell and Dr. Sara Sakamoto for their help with this project.